Dear colleagues, good afternoon. So it's a pleasure for me to welcome you all and to share our experience in terms of our solutions and the working with geological data. So using these solutions to cover all the periods, from the exploration to production and to closure. So I will start this presentation, and then my colleague Alexey Zhelin will catch up to complete it. So the geological software, so we are just keeping track of all the developments globally. So we identify the current trends, and then we follow up those trends to trying to satisfy the needs of our customers. So obviously there's one clear trend that we see as part of the major companies, but also smaller players would be asking for the same kind of products. So what I mean is that they would like to use various software, but as part of a single software ecosystem in order to avoid any duplication or loss of data that will be detrimental at all the stages in the mine life cycle, from exploration to production. So with our specialists, as I said, we're keeping track of all the developments, and this has been the project that we have concentrated our efforts on for the past several years. So now I'm talking about a single ecosystem, and a leapfrog software is one of the benchmarks in the market, but this is not the only product that we are offering to our clients. So in addition to that, you may see that our portfolio has been broadened, and that it included also different products such as the GeoSoft and EGS programs, and a Blockbuster, the one that you can use to process block models, eMark, that's core photos, and machine learning tools are there. So solutions. So this ecosystem consists of solutions just covering all the sciences that are there, just at the development stage. That's with geology, hydrogeology, geochemistry, geophysics, geostatistics, and then environmental science. We do have specialist software to process data for contaminants and landscape characteristics, so that can be used as a cross-section view of a specific spot. And there is just one connecting link that is central. This is a cloud-based solution that enables communication between all the software products, and this is just one single space that brought together all solutions into the ecosystem. And just let me briefly comment on each of those components so that you could have a better understanding of the ways of application of our solutions. So I'll start with the MINEX Deposit, a cloud-based platform to process data that simplifies collection, control, and transfer of data, enabling also for data control, and this can be then communicated to Leapfrog, Geo, or other products such as OASIS Montage. So this is quite flexible and convenient for you, so you can even have it installed on your mobile, so you can be on site, or you can process correlated data just at any point in time. You can get access to the software, and then just it's very convenient. As I said, you can use your mobile for that purpose as well. Now I'll go into the next group, which is GeoSoft. So that includes OASIS Montage, just the leading program designed for geoscience data, the processing and geophysics modeling, and it is well known among all the specialists. So it's a large set of tools that provides a different solutions such as 3D modeling. So, for example, your magnetic surveying can be translated into the magnetic sensitivity among the rock, and usually it is better used by geologists as compared to these anomalies maps that are more conventional as a solution. Next, that would be GeoSoft Target. So it's a slightly simplified version of OASIS Montage, because Montage includes 25 models, and then for Target, we have just a better price offer, and then it can be used as a comprehensive set for junior companies. So, as I said, that it's more lower in terms of pricing as compared to this montage, but it also provides many possibilities. I mean, like leapfrog, so you can using frameworks and contours, and then again, these tools that can be used for the purpose of the processing the data. So and then next we have leapfrog. As I said, that's a flagman program for the purposes of geological modeling software, and that's a 3D software. So leapfrogged, I mean, it has been developing at a faster pace. So in addition to geological modeling, I do know that many companies would be using leapfrog for this block-based mechanical models. And then this includes Russian assets. So, and then Central, as I mentioned, that's our connect and link for all other solutions with the ecosystem. So Central is a cloud-based solution. There are some obstacles in Russia towards the use of this cloud technologies domestically, because right now it is supported abroad, but nevertheless we do know that many companies are using this application, including several companies in Kazakhstan. So some Russian companies have already started piloting this software, and they seem quite promising for their future use. So a few words about Central. So that is a dedicated solution that enables you to just store your geological model, so that can be considered as a digital twin. So it is with a 3D model, so that would have a certain history, and then you can use it for the prediction, and then you can see what happened in the past. Therefore, it's more like a digital twin, because it will retain all the information, all the changes that you made to the model. Plus, you can use this data in order to do prediction and analysis in the future. So the Central, as I said, this is the connecting point. It goes beyond simple communication or exchange of data, just a platform. So there is a storage room, and you can download this data, and that the data can be uploaded by any person, again, at any given point in time. So this provides a direct access to all the information that has been stored on it. Just by way of examples, I'm demonstrating it on my mobile, so you can just check the performance of your teams to see what geologists are doing, what they have done, so you can find the people responsible for these or that task, and then Central will be sending you also the notifications of all the projects that are underway and the people that are engaged as regards performance of certain tasks. And this can be further used as a very useful tool for consulting companies. So you will be authorizing those companies through your portal, and then you can authorize access, just limited to a number of consultants. Or so on the one hand, so this can be a restricted access, but on the other hand, so you can make it broader, and you can include all consultants in your environment. But we are just moving, in this alone integration, and just leapfrog and or this montage target. So these are better positions for the purposes of integration. And it was several months ago that we made this acquisition of Imago company, the provider of cloud-based solutions for core photos and related information. So it has been integrated with our leapfrog system, so it can be just directly connected to them, and then you go into a drill hole, and then you look at the core. So that is also another kind of convenient tool that can be used for mechanical documentation or statistics for your core operations. So just, again, at any given point in time, you can check this data visually. So I have covered mostly all our solutions, but this list is not closed yet because we have other solutions to offer. And right now I would like to show this map, so that all the operations are just going from exploration to production. So if you look at the scheme, then you see the line going beneath it, and that is representative of specific stages. in the project. So just for my presentation, I will focus on exploration part. And right now I want to show to just by example how to process data using our OASIS montage software, and then to put it on our platform Central, then to be forwarded to the geologists, to those producing geological models for drilling operations or for further exploration. And just for your information, and this is a very interesting fact, so that's MINEX Consulting company from Australia. So just they surveyed the discoveries of 4,000 deposits, nearly 4,000, because they were within their database, and then they looked into these different ways of discoveries and explorations that were more promising and successful, like looking at these prospective areas, and then followed by specific discoveries. So the scale of the operations varied from one project to the another. Just I suggest we take a look at two recent ones. So these are the graphs, and then you get the scales just oriented towards the 100. So the license areas on the left hand, and on the right hand you find those methods that we use to identify points for drilling. And you see there's a certain similarity between the two. However, so it just would be going from ore to ore is a key method. Probably it's colored in beige. Just we see along the evolution of geophysics, and at the very beginning of the century, we realized that the role of this method, especially when selecting this exact spots or drilling holes, and that the role of this method, as I said, was overarching, and then it contributed to the successful discovery of mineral deposits and other promising prospective areas. Just if we just take this data as a focus, then we then can use our solutions, as I said, in real time. So if we're going from ore to ore, you would be using our geological modeling that will be keeping a track of all this mineral license stripes, just making predictions as to where it goes, and then probably will it change its course or not, will see any technical deviations or not, and that's deposit, my deposit, the software and referring to next to OASIS montage and targeted that are designed for geochemistry and geophysics can be covered by OASIS montage and AGS solutions. So to dive deeper into this topic, I'd like to say that our solutions can be used for various purposes and methods that can be seen on the slide. So then next slide, and from that I'm going to move on to my laptop to see just this real-time interaction between all of the components and modules of our software. So we can take this magnetic surveying field data from one of our sites so that I visited some time ago. So we take this magnetic data, and then we're using the OASIS montage, then a line can be built, and that will be communicated to Leapfrog. So this mapping will be used, to improve either your geological model or your interpretation of the anomaly in question. So then we'll be looking at this interaction, communication between OASIS montage and Leapfrog across all components. And to conclude, I will just demonstrate just the way in which OASIS montage can be used as part of Leapfrog environment. I would just like to make one mention. So there's a direct link between OASIS montage and Leapfrog, so you can take this model data to produce your models, but Leapfrog will be connected next year only. So let me demonstrate. That's OASIS montage. the software I've opened it. So before we start any activities or operation, this is a set of operations, will be a traditional one, and then say you need to find this base. So the base will be just basic step for any planning exercise or operations or geophysics if you need this base data. Again, we have this service, so you can download the data or upload it through, you can upload it through the central server with geophysics, and they just selected one area in Australia. So because they have a vast amount of data and it is open, so right, we are now uploading the map supported by satellite images, and it just takes a couple of clicks to put this map on your screen. So that now we can use it, and in addition to that, we can also start the server to search for information. So we just download in this free data. So that means just as an initial step, you get this some knowledge and information for the area that you want to analyze. Now we see it. This is the server. And Australia, say that magnetic. So now we want to use this national total magnetic intensity map. So we'll be downloading it. Then this will be digital data, but we can run and an inversion process and just see this is a very clear picture of magnetic field, and then we can go into details and we will be selecting the certain areas and we'll be getting more information about those areas that are of great interest to us. Plus we can use it for topography and get these images in various formats. So we gather all this data together and then we send it to our central. And it's uploading to central instance, again selecting this data for transfer. So you're just selecting it by ticking those blocks and then sending them. I just not selected them previously to save time with that exercise. Right, when all this is done, we get 3 databases for variation station. There's a GPS data and magnetic data. What else can we do? So we can put them together, the 3 databases, the 3 data sets. So we just will be combining them using our OS's montage solution just for this new columns. We'll be adding coordinates. So any information can be then put in our program, and then we can also use data filter, and this can be done automatically. So just let me put X, Y, Z, and we'll start mapping. Again, this can be easily done. To add in data, GPS, variation station, and then just several tools can be used just for the calculating this variation field and magnetic fields. So when here comes the mapping, so peaks can be removed or some lines can be adjusted, and then we start interpretation. Again, using this inbuilt tool. For instance, for just any gaps that we see can be interpolated and filled in with actual data rather than leaving it as a blank space. So then we build lines of mapping that will go beyond the line. So that's our grid for noise, and so with lots of noises, then we need to set filters just for the purposes of demonstration that it's very interactive and intuitive just don't believe geophysicists that they say that it will take a long time and much effort. Just this is not the case, because that was in the past. Currently, we have this efficient tool such as Leapfrog that can be used for interpretation. Next, so when our grid or map, when our map is ready, so this can be saturated with all kinds of data. So geophysics, as I mentioned, can be used as part of our environment. Yeah. So geochemical anomalies, and then can be put on our map. So this is a magnetic field, so using this database for geophysics and surveying. These are coordinates and the results, just to see these symbols. Again, mapping, putting it on the existing map. And then, again, once this is done, it will be communicated to Central, so the specialists from other departments could use this information as well. So next, we'll be analyzing this data just through Leapfrog, these maps and lines, because often those are communicated without any possibilities of analysis, and then geologists, they'll be using them, but not properly, without interpretation. So what I am saying, that we can use this data to build a 3D model, so that will be the inversion of geophysical data. So we take this magnetic data we previously demonstrated. So then we're using these physical fields and characteristics that will provide this model for magnetic sensitivity based on the magnetic surveying data. And as I said, so this then be used for the purpose of interpretation, the anomalies. So, and if we don't know the properties, then the interpretation may be on the wrong side. Just this inversion of fields, be it gravitational or magnetic fields, just they will be all downloaded into Central. And then Central again will be using grids and geological modeling and interpretation that can be seen as this lower part of the model. So Central, I have mentioned it several times, and I would like to show you how it looks like. In fact, so this is Central. So your model is in here. So the project that actually you built, that all the changes that can be traced, and then dates of change, and these are branches for your project. Again, several branches can be added. And then you'll be uploading data for these branches. Remember that I've shown you with your mobile phone, smartphone. You can use it to control and use this data as part of cloud-based solutions. I mean, from any browser and from anywhere in the world. Users, that's about permissions. You can assign or you can add as many people as you want. So you can just through the viewer, editor, and owner. These are the three categories. Next, data room. This is storage area. That the data room will include all information, data that is received from various solutions. You can get it unloaded and again at any point in time. Then the history, that history of changes, users involved, and then next we have notifications. Notifications will be sent, and whenever you have any change, then no matter whether it's done by yourself or by someone else, Leapfrog. And then next, what we can do is we can use this topography. So through Oasis Montage, probably searching through the data. So this So we see this model of leapfrog and a central that directly communicates and just gets information from the server. But I want to connect and I want you to see it for yourself. I'd rather do it online right now than showing it in the video. It's a pre-recorded example. I suggest we wait a little bit. You see that all the software is reliable, but needs good connectivity. So with changes are introduced, that this will be saved on your machine, and then they can be just unloaded in the cloud. Again, at any important time, even if your connectivity is not stable, so that the software works in such a way that it will be just unloading and uploading just in the process. So, and if just connectivity is gone, then there will be so the downloading process will just stop for a while, and then they'll continue. So as soon as connectivity is stable again, so that we have this as an inbuilt option both for Leapfrog and Oasis Montage. So this has been a download from center, so getting it right. Without going through topography, I would like to show geophysics. So that's importing from central, and then these are all the models that you can access with the central. Then you need to select one specific project and then just one specific time, and these are all the options available to you to retrieve your data from the server. In addition to that, there are files, so you can use it in any format, or you can save it in any format, and then you can use it for the purpose of an interpretation. So this will be importing, the import of physical data. And one more thing to be noted, that these are digital data rather than pictures, so that you can use this value filter for anomaly. And you can also process this data of magnetic grid, so this will be downloaded as 3 profiles. So using these profiles, and you can also get a map, say a geological map that you have, and then you'll be using it with Leapfrog to build your geological model that will be used as a conceptual model for your work. So this will be adjusted and also updated at various stages of operations, such as geochemistry, for instance.
So here are these geochemical points, and we can do with them. Also, we can show gold. We can apply different formats here using digital models, and with the help of them, we can add the ISO services of geophysical anomalies in Leapfrog. Thus, we collect all information, all data with the model of planning of the calendar of drilling. We can look at the holes at different angles and then export it to the drilling teams. They're also going to implement these works. We also can upload data on magnetic sensitivity of the rocks. I showed you this inversion of data in Oasis Montage, and thus you can have a general picture of the situation on this site. Next point, I want to show you that after implementing drilling, that's the next stage, we have already checked the anomalies with the drilling, then we can document it, all these activities in MX deposit, and also to upload them to our Leapfrog through Central. We import the data, we connect to the server, we go into the data room. Here we have a special folder, drill holes, and we connect these holes automatically. from Central. As you understand, Central is one of the unified source of data. It means your colleagues will always work with the same data as you work, so there's no final version or final version 2, 3, and that allows you to have the standard data and to reduce the number of errors in modeling and when you operate with data. Thus, we have implemented drilling. It is carried out already. I'll switch off the magnetic map. And now these data can be used for the detailed geological modeling and to obtain this type of image. Here, based on our drilling data, we have built this geological model. We have different rocks here, and we also date on the testing. We already see the ore bodies that have this type of shape. We'll see that immediately with the results of our drill tests. And as you understand, we also have the model that assesses resources in Leapfrog. After drilling, you can assess your resources of the site, and thus to evaluate the potential of your site. It is done with the help model H that can be additionally integrated into Leapfrog. So you perform the new assessment on the wireframe that has been characterized as the ore area. So easily you make the assessor a variogram for the assessment. I'll do it in real time so you can follow my actions. It's rather easy if you are really experienced user and understand what are you doing. So now we create variogram. Of course it's simplified. I just meant it on the main angle of our ore body. I'll just add some elements on different axes. We save all this, so it looks like this. For our ore body as an ellipse, it is shown here on the map, on the model. This one in the center. Then we create an assessor, RB assessor. It operates quickly and it will perform calculations very quickly. We set the parameters. It is rather precise, accurate, just accurate settings. I made it on default here. After it, we make the block model for this area. You can see it now. We have uploaded only geological model. We also project all the data to our block model. I'll switch off the lithology, which we may not take into consideration while it is calculating. So this is our ore. Blocks are painted in different colors, mainly by red. After assessment, we can include different content, what we have in different blocks. You can see it to the right. And then we can generate a report on this ore body, on this ore deposit. We can also choose the parameters, then to set the units for measurement. And we'll have the calculations of the board content 1 gram per ton. This information that resources of this site on the parameters that were set, mainly by default. So they are here in this area, about 8 tons of the useful component. Here I want to stop this. Thus, I have demonstrated the process starting from the exploration activities up to the assessment of the resources. The next stage will be presented by my colleague Alexei Zhilin. And now I give floor to my colleague Alexei Zhilin. We have a question on the first part. Yes, of course, you're welcome. You may ask a question. Have you performed any kind of audit, any kind of analysis? Analysis of what? Can you after implementing or after you create the model, when you open the body, what are the percentage of correspondence to the model? So it depends on the project. It depends on the number of data, of the number of holes. I can't give you any exact numbers, but sometimes it's rather good. If we have a lot of data and if a lot of information is uploaded from the very beginning of the project, then I cannot give you exact numbers. Yeah, maybe if we discuss the certain project, then yes, it's a kind of pilot project, and here everything is very simple. On the real, of course, in reality, it's a bit more complicated. We have already tested this set of data, I would say, and also this set of solutions. A lot of companies are now use this software. What I have demonstrated to you, many large companies already use this software, and we train the specialists when we use their experience, and we also develop the specific projects for training. And in Russia, who are your customers? We have users who may choose different solutions. I can name, for example, Polus, Polymetal. They are users of our software. And not only Leapfrog and Oasis Montage. These are two main solutions which are used, because this link that was demonstrated, it becomes very, very popular abroad, everywhere, globally. Thank you very much for your attention. Okay, good day, dear colleagues. I'm a geologist, Zhilin Alexey from Seequent company, and I'll present the second part of our, software and our works. So continue this topic of the United Digital Space. We were using how these solutions can be applied to the different activities, mining activities. When we control and predict the quality of the deposits using the software Seequent. We will talk about the underground works, underground activities. And this is, it's an invented case. It's not a real one. So there can be some technological errors, but the idea will be presented quite correctly. So now let's pass to the case itself. We're talking about the interaction of geological services, hypothetic geological enterprise, then the team of operators, and, the engineers. Geologists, they're looking at the concept of the deposit itself, and also they want to identify the localization and the area of the mineral resources. Then we also have designers in our team. The main things that we have to look related to the software, what are their duties, what are their responsibilities? As I said, geological team, they mainly create the geological resource models. They also have to perform the calculation of the quality of the resources, because and geologists, they have to have the data from the other departments of already performed activities and the data of the pre-exploration works. Of course, on the data that they receive from the mining engineers and from the geologists, this is the resource model, they have to make some kind of conclusions and to plan some activities, how they're going to continue the exploration further. And the designers, the mining engineers, they plan they design and they correct the already performed activities, taking into account all the data. So this is the scheme that we're going to consider. Okay, just the only thing that I need to do is to use our application. So, dear colleagues, let's continue. We'll go ahead. We have four projects that we are carrying out in one digital space. We'll start with the major project, a geological department. Here you can see the tree of the project. You see there are two hypotheses that we consider. There is not a single solution among the geologists. And we have two versions, and we're working on these two versions in parallel. Can you understand? The real enterprise is not going to follow this model, but just we use it as an example. Next, we have project of our mining engineers. They're not, you see, we have to use the certain technologies, so they follow two stages. We have planned two stages for the activities. Maybe you cannot see it quite clearly, but you can see that they're covering mainly the western areas. And there is the second stage of the works in the northern part of the model that has already been covered. So the miners have already went through these two stages. We're not going to speak about the operating team. Let's come back to the geologists, because everything depends on them. The main things depend on them. As it was already shown by Alexandra, the central allows you to have all the tracking data of the project. Let's go to the initial data. What do we have from the very beginning? From the very beginning, we have a kind of area. We're not going to consider the entire model. We have, this fracture area. It was modeled, and the rest we aren't going to consider the other parts of this model. And we have some kind of vision or hypothesis on the resources and distribution of the resources and mineralization in this area. Let me go a bit further. You can see it here, that this is the area of the ore location. It can be correlated with the database. Why? Approximately because it's a digital, model. It's going to work as a resource model. But I want to warn you from the very beginning, it's not correct. We made it in order to save time. Let's assume that this is a resource model in this case. I'll switch off now. And I'll show you only the vivid mineralization. A kind of bubbles, that we can see in the space in this model. So this is the concept, and this is our initial concept. We start with this, our starting point. Moving ahead, after some time, geologists, they obtain some additional data. That's the next iteration of the same project. I'll download it and we'll continue. They consider in space some other, fractures. This is our fracture area. And we have one more site here. Why do we make such a conclusion? So apart from the digital cover, we have The digital filter was demonstrated by Alexander. And here we can define the certain area. If we, again, download the most mineralized areas, we can see that they are localized approximately in these areas of splitting. Again, we can make an assumption about the alternative version, that there is a mineralization which is connected with this area, with this side. Can you see it here? We have already applied this digital trend. All this area it has an orientation which are given by this system. This is an alternative version. I showed you two trees in the beginning. The geologists are working in parallel on two hypotheses, and this is the second hypothesis. And we'll see how they will be developed in future, and they're going to be developed. So what is the next problem? We have two hypotheses. We have some kind of data on our mining works, and now we have to launch the operation, the production already. If we have to launch the production, let's pass to the tasks of our mining engineers. I'll open the project. What do they usually start with? I'll show you the version. Let's agree that the mining works start from this moment, the production, stage 1. We have already started with the main production, and we have 9 loves. Starting from this point, we move forward. First step that we required in interaction of these two departments, that the data from the mining engineers of the activities performed by geologists. Let's come back to the geologists. First step. This is our main version, with the resources which are not connected with the and then we see the third step, when we add some kind of calculations here. Let's have a look what happens here. Here we see the cut of one of the horizons, and here we see these 9 loves. We added the block model to the project. I'll add the calculations that were performed, and we'll see them on the screen, and then I comment on what we can find here. So here we have created the block model. I'm not going to waste your time on how we made this model in our software. Just to simplify, we have introduced the variable on weight, variable, and the board content was taken as (5) that we defined by OR. This is board content. And you see ore, we consider ore that has everything that has higher content, higher grade. Everything which is lower, this is not the ore. So we have these parameters. And we have also used 2 filters. One filter that filters only the blocks that go into the lathe. And the second filter that calculates if we click on the block of the model, we'll see apart from the standard fields, we have also block model, which is edited with the with the already performed activities. Every block depends on the certain activity and also is characterized ore or not non-ore. Also, we have calculations on the content of the ore and the other rocks, and also take into account of this number. We can calculate the coefficient. How it became possible, where we have only geologists. We have the kind of digital cover, and when we projected it to our model, we have the content of gold in every block of the ore. To have the information, we ask for the geological model on the mining activities on the product. The same functionality. We take it from central. We take this data from the central. I have already selected the project, you see it, and here we can also select any kind of sets of the production that was done on any stage of the activities. Here we have chosen the first stage. That's what you can see on your screen. What next? The model of the miners have also the whole body. It shows you the block of the already performed works. The model also going via central, so it is taken from miners. It is projected on the block model and performs the certain calculations, and you can see these calculations. So this is the first thing. In order to pass to the second stage of our mining works, or to plan 2 different scenarios or 3 different scenarios, we can reload the number of the activities performed, and on each scenario we can use further the geological data. I'm not going, as Alexander, to use maybe not very reliable internet. I'll just pass to the next version of the project that already has the next step in it. So this is version 1 and this is version 2, second stage of the version 1. It differs from the previous project only by the set of the already performed works that we have taken from the miners. You see, we have a little bit different image here, different set of activities. So this is the next stage. The block model itself, I'll show it in detail. It is now colored on the coefficient of depletion. It's either ore or non-ore block. So it is either depleted to 100% or not depleted at all. So it is colored according to our resource model, our digital cover. You can also see the area which we can call the entire body, or the one which is taken from every type of the production. If we look at the report of the block model, it's the same. It's similar on all block models that we'll see in this particular branch. Now we have a recalculation, and this recalculation will be continuously performed. It means that you all have very relevant data. As soon as you add the new data, all technological parameters will be recalculated automatically. Just one thing that I want to show you, I allow myself to reduce a little bit the report So these are the components of the first and second stage of the works performed. I just want to make it a bit shorter and more compact. Here you can see different parameters. This is the average content, the coefficient of the depletion, and this is our minerals. That is the second stage. When we look at this branch of the project that has this hypothesis with that the areas of mineralization are not connected to any kind of phenomena. If we make another assumption, if we say that this is not a correct hypothesis, then we'll view the alternative branch of the same project, of the area or the version where we assume that there is a kind of space trend. Let's consider the following thing. We need some time to download the data. So this is the second stage of our mining works, mining production, when the area of mineralization is, connected to the splits. You see the coefficient of the mineralization is lower here, not so high grade of the ore. And if to compare this situation with the hypothesis about that the areas of mineralization are not connected to any kind of phenomena, then we see the difference. Can you see it? When you look at the blue areas, that resources are a little bit lower. It means we have the higher coefficient of depletion rate. And the core stone, we have two hypotheses, two versions. And with some fantastic way, we don't need to follow one scenario or the other scenario, but at some point we have to make our choice because we cannot follow different scenarios. Equipment costs money. Then we come to our operating teams, to our operators. And we set the task, the objective, to continue the exploration on the side areas. How they work, these operation teams. They again obtain data both from project 1 and project 2. See here the folders. Here they have the wireframes taken from the digital storage. I can show you it once again. This is our tree of development of the project on geology. I'm now following the main version without applying the trends. So here I have one of the last versions, and all these data is taken from this project. I just will drag them to this window. We will not see anything new. You can have a look here. I will just check whether I am on the right altitude.
It's the elevation. So we'll look at our operations. So that's all part of one project. So we haven't seen the split, not yet. So here we can clearly see what's been done in terms of mining. And that's scenario number 1. So the one that we are going to further validate. And here we go with scenario number 2. So no difference on the numerical side. Now So let me use this prompt. As I said, in terms of numbers, on the numerical side, so it's exactly the same. So the situation that we are dealing with based on the data is the prediction for minerals allocation, so that for purposes of exploration, we'll be just doing this exercise and taking a material from the points that are highlighted on the screen. So we have this 0.3 for blue and 0.7 for yellow. So there are two lines on curves, that's exactly the same. So heading like 0.3, 0.7, so we can consider this to be actual data, and the configuration actually indicates that it is very likely that this scenario for quality distribution that is based on the trend that we build. So we see that line goes from the north to west and then to southeast. Add to these numbers. So we take it from the baseline model and from the advanced scenario, and probably there is an inconsistency that can be observed just as related to the so-called actual output. Now, so now from these advanced layers, we need to take this data and then to incorporate them into our second-tier projects for this hypothesis based on resources. I would like that to do it like online, but no, it's because of connectivity considerations I decided to do it before the event, before my presentation. So just let me show it to you, that loading project as an alternative. So these are alternative scenario that includes the trend and properties. The points are part of the project, which we can see, and they are also part of the baseline scenario. So importing these polylines and points, so we're just importing them from the storage or from the central. And as it was explained earlier by my colleague, so the central will be available to those authorized users that we can assign. There's like peer review or initial projects. So from these, I can take any data set. So just right now, I'm taking data for polylines. And that's what I did, like reloading. Then I can use it to update my exploration project. So using this function, I can have this data incorporated in our numerical environment, and as a result, so we see these two charts, like pre-advanced study and post. And I would like to draw attention to several aspects that are very typical of the process that I've just described. So that's the project tree. One, just there is a block models that is colored, and then two branches of the project. There are two smaller branches because this is representative of our initial versions. And then at the more advanced stage, so we take output from our miners, and these will produce the second more advanced versions consisting of blocks that enables us to go through all operating and production parameters. So this is just an example, and there will be yet another iteration when we'll be adding more data from exploration. So for each of the projects, so we can As I said, because if it's exploration project, then exploration data will be incorporated. So if a geological project, then we can incorporate data that we receive from geologists, respectively. And as it's a mining project, so we have this two-stage mining project with the same, set of outcomes or production output. So then we can just go with a different scenario for mining, and then it will give us this very actual, interaction scenario for the operations of the three departments or services concerned. So now I'll be happy to take your questions. Alexei, I do have a question. So there is one question from the audience. So that's about, this module incorporate the database. So do you plan to use this tool of administration? So do you plan any improvements? So what I'm saying that just we are working with a very basic version, so it is impossible to add errors. So we have to drill holes, and then sampling is just used at the first stage, and then we want to add more sampling. Then the system just stops operating, so we need to then take this all previous drill holes and then put them into newer format. So I would like to see it in a more friendly format. So how much time it will take for us to get this one? Right. So again, I've been waiting for it for a number of years, and now we get this calculator for data and also trash fields that can be removed. And this is a good option. And there's another option that you can add the second data set and the third data set for operations at geology and so on and so forth. And it's my hope that because I can only hope on this respect, because we are a regional branch and we are developing, and it's the first time that we are taking part at this user conference, and this is yet an indication that would go to our headquarters. Just Russia just is a different kind of jurisdiction as compared to New Zealand. So just stating the position that we are a very serious market. And so they hear us, and that's why I believe they will be developing the software. So what about spreadsheets? Whether you would like to see leapfrogs as software friendly, so more friendly and more adaptable to use the spreadsheets? I don't know yet, but we are looking forward to receiving this new option. What we are doing, just we are communicating requests that we receive from the actual users. So we have just smart people, brilliant people in Russia. Just you send your proper request. Just as I said, we can only communicate those requests to the headquarters, but at the regional level, we do want to set up this liaison office just for to make sure that your requests and needs are met. So just for the time being, we need to work with the functionality that is there. So say thank you very much for your presentation. Can your software be integrated with a SIM model, the one that you use for equipment calculations? So I'm not a great expert on equipment calculation software, but it's all about data. I mean, what kind of data should be downloaded, and then what kind of data will be just imported. Wireframes, okay, that's fine. We can use with any types of wireframes. At DXF, that's the most traditional, the conventional one that we can use for this purpose. By the way, our colleagues from international companies, because my project is far more simpler, but my colleagues, they actually delivered a very robust project that included for the calculation of mining operation, because we would be using an optimization that tool, but somehow they managed to include cost calculation. Probably they were used with a reference points, and then with coordinates you can calculate the cost based on a specific formula. It just the cost is there, and if there is an interest, on your part, and that you have some data that is open, then we can give it a try. So we'll try this. We'll sign a non-disclosure agreement, and then we're piloting with a smaller data set. I'm not very comfortable, talking about those things that I haven't been personally engaged with. So thank you so much. But the central another question. So the data properties, these are based on what? Just I'm thinking. So if we want to use central at the corporate level, so that will be developed as because this is a cloud-based solution, right? But with cloud, and that's the data management tool. I mean, is it linked to someone? I can explain. So we have this Azure cloud, and previously we could also have our cloud integrated with the corporate servers, but then we decided against it because of complications with the IT maintenance. So right now, as I said, so we are looking towards localizations because we want to have our cloud based in Russia. So, but is it from Microsoft, like a storage? The data is stored by Microsoft. Is that correct? Yeah, that's correct. But but can we get this direct access? I mean, just bypassing interface? No. There's no direct. All access will be linked to central only. Right. So when you open projects, these are locked as a status. So it's not possible to have one project edited by several people at the same time. And no, it's not. Thank you. Thank you very much for your questions. And we actually have touched upon, the most, soaring points in our projects. But these are the questions that are important to us because for corporate applications, these are just key points. Right, just let me comment on this. Remember this timeline? And so when we just were explaining, so we are just starting to use new formats. So in order to integrate new software, just going through IPR, that is open access, so our cloud will be communicating with other software and other programs, and I think it will be by the next year that we'll be able to make a presentation. But just projects, or just can we go to the level of actions or to the project history? Yes, you mentioned that you do have this project history, and then is it traceable, like actions by whom and where? Do you have some? No, there's not. Just you can add a point, and then you can move a string. So because that's what I'm saying. So we get the final result. Yes, the files are there. We can get this files multiplied, but we don't get into details. Just I cannot verify. I cannot make sure that specific functions were undertaken by specific people. I mean, they're responsible for them. But then you can split your projects as a suggestion into components, and then you'll have just a person A responsible for first component, person B, right? But this is all about the way you structure your work. It's not the inbuilt function with your software, yes? And any further questions? So with that, I would like to thank you for your time and patience, and see you tomorrow then.